Okay, so we're going to go over the atomic structure periodic table review. You can pause the video or fast forward the video if you already have some done. I would rather you try to solve most of it and then you check with me on my paper. Okay. This first top section there, remember I said that we are not going to do this section because it's not going to be on your test. Now you can still do it because you do have the notes for it, but you don't have to do it. This one. Okay, so starting here. List the 3 subatomic particles' charge location in the atom. The first particle is the, of course, proton. You have a proton first. It has a positive charge, and I'm going to find that proton in the nucleus. Okay. The mass of a proton will be 1 AMU. Okay. AMU stands for atomic mass structure. Let me write it off to the side. Mu is atomic mass, unit. There we go. That's what it means. Keep going. Next particle is the neutron. The neutron has a 0 charge, has no charge. And I find that as well in the nucleus. And that is a mass also of 1 AMU. About the same size as a proton. They're slightly different, but it's relatively the same. And the last one is the electron. An electron has a negative charge, and we're going to find that in the electron cloud. So remember, that's where the energy levels are, and so the different energy levels, all the energy levels in total is called the electron cloud. And the weight is approximately 0 AMU, so just 0. It's so small that we're not even going to worry about the mass. So here we have our table, and we're going to start filling in. So take a minute, try to do it yourself, pause it, and then play it whenever you have it. The first one, I have 10 protons, 10 electrons. So if I have 10 protons, my atomic number is 10. On the periodic table, 10 is neon. 10 protons, 10 electrons, so I have a 0 charge because they both equal each other. Both of these equal, so I have a 0 charge. And neutrons. So to get neutrons, I need to know what the mass number is. Now, if I don't have a mass, meaning I don't have protons and neutrons, I'm going to get my mass number from the periodic table. Neon is over yonder, right there, 20.18. So my mass rounded correctly would be 20. And so to get neutrons, I'm going to do mass number minus protons equals the neutrons, 10. Chemical configuration, I need my symbol first. My symbol for neon is in E. The atomic number goes at the bottom, 10. Mass number goes at top, 20. And the charge, you can put the 0, you don't have to put the 0. I'm not going to put it because it's a 0 charge. I'll explain the next one, and then the rest of them I'm just going to fill it in. Mg, there's a 12 and 24, so my atomic number is 12. My mass number is 24. My protons is 12. This is called Mg. There's no charge, so I'm just going to say this is magnesium. I have 12 electrons. And to get neutrons, it is the mass number minus the protons, so I'm going to get 12. 0 charge, so don't even put a charge there. The rest of them I'm going to fly by. Make sure you check your answers. So pause the video and try to do the rest. Okay, this one actually had a charge, -2, so I put the -2 there. And the reason why it has a -2 charge is because I have more electrons than protons. I have 16 protons, 18 electrons. 2 more electrons means I have it's more negative, and it has 2 more electrons, so -2. This one, my protons is going to be 20 because my atomic number is 20. So since they're different, I'm going to have a charge. I have more protons, so +2. And okay, and I made a mistake. The name of this one is not sulfur because I have a charge. Since I have a charge, this is wrong. And this is called sulfide. Change that ending, ion. I changed the ending because it has a negative charge. If it has a negative charge, then I change the ending to IDE. Whereas if it is, this one's going to have a +2 charge. Since this has a +2 charge, it is just calcium ion. Atomic number here, and mass number. There we go. Keep it going. This has a charge, so it will have the word ion in it. It is positive though, so I'm just going to write the name. Beryllium. How does it? Oh, I know. Lium. Ion. Atomic number right here. 4. Mass number up there. 9. Protons 4. Electrons. Since it has a +2 charge, I have more protons, less electrons, so 2 electrons. And neutrons will be 5. 9 minus 4 gives me 5. Here I have sodium ion with the +1 charge. Oh, whoops. There we go. Sodium ion with the +1 charge. So this is Na, and I already know that it's going to have a +1 charge. I still have to put the atomic number in the mass number, but I can at least do that part. Atomic number, it is number 11 on the periodic table. The mass number, if I round it correctly, it should be 23. So protons is 11. Electrons, since it has a +1 charge, I have less electrons, so that is 10. And neutrons, 23 minus 11 is 12. And there we go. Next part. Let me move this. Perfect. All right, decide if the following are isotopes, yes or no. So if you don't know what an isotope is has the same number of protons, but different neutrons. Okay, so it has the same number of protons, or it's the same element, and it'll have different neutrons or different mass number. Okay, because the neutrons is the same as the mass number. So let's go here. I have the same protons, different neutrons, the exact what I just said. So yes. This one, I have Si and I have P, 2 completely different elements, so they don't have the same number of protons, so no. Different number of protons, no, because that makes them different elements. Same protons, different neutrons, yes. Okay, here they want me to calculate the average atomic mass. If you don't remember what the equation was, remember it's mass of isotope 1 times its percent plus mass of isotope 2 times its percent plus, and so on. Mass of isotope 3, and you just keep going until you run out of masses. Okay, this is blurry. Maybe that'll help. So this first one, I have this percent with this mass, this percent with that mass, this percent with that mass, this percent with that mass. All you got to do is multiply the percents and the masses together, put it in the calculator, boom, you get your answer. Oh, I need a calculator. Trigger. All right, here we go. So that is my first percent. Oh, actually, let's get the first mass, which is 54. That's my first mass. Okay, it is right there. And with that percent is 5.82%. Now, you cannot put 5.82 inside this equation because I cannot put percents inside this equation. Yes, I need the percent, but I need a decimal. The only way you can change this to a decimal is to divide by 100. Now, those of you who want to move the, move the decimal, go ahead. Just make sure you're moving it correctly. If you don't know what I'm talking about, just take this number and divide it by 100. 5.82 divided by 100 would be 0.0582. And there goes the first one. Let's go to the next one. Mass of the second one is 56. And it is, if you divide that number, this one right here, by 100, you're going to get 0.9166 plus 57 times 0.0219 plus 58. Again, divided by 100, you should get 0.0033. All that's put into your calculator. Give me a minute. You can fast forward if you think I'm taking too long. Oops. If I make a mistake, don't tell me about it, just let it be. I got 50. Yeah, seems right. 55 point. This was in, this percent was in 3 sig figs, this was in 4, this was in 3, this was in 2. Ooh, yikes. Not very good sig figs for this one. Let's just put it in 3, just to say we can. And I'm going to put AMU, because that is the unit for my mass. Okay, next one. Naturally occurring element X exists in 3 isotope forms. That one with that percent, that one with that percent, that one with that percent. Calculate the average atomic mass. The exact same problem. To do this one, make sure if I give you 2 different masses, but they're the same, so like X28 technically goes with this one if you round it correctly, you pick the more accurate mass. So instead of putting 28, we're going to put the more accurate mass. We're going to put 27.977 with its percent 0.9221 plus there it is, 28.976 0.0470 plus 29.974 0.0309. Shablam. Plug it in the calculator. And I'll get 28 point, let's see, did I do 6 figs? This one has 5, 5, 5. Let's put it in 5. I understand the percents might not be in it, but let's put it in 5 anyways. If you put it in 5, it'll be 28.086 AMU. Alright, next. This one wants us to calculate the percent abundance. Remember, there's 2 ways to do this. You can use a system of equations where you're getting x plus y equals 1, and then you have to factor one of them out. Or you can do substitution. I'm going to do it the substitution method, but as long as you get the correct answer, it's whatever you choose to do. So we have Cl, and we have 2 masses. Mass number 1 is 35, mass number 2 is 37. Then I'm going to have percents for each of them. That's what they want me to calculate. What is the percent abundance? I have no idea. I have no idea. So I'm going to say X and Y. But I know the average atomic mass is 35.4527. That is actually on your periodic table. So how we're going to do this is we need another equation. X plus Y equals 1, right? Because if I add these 2 up, in decimal form, you should get 1. So I can solve for x. If I solve for x, I'm just going to subtract y on both sides. Wait, is this what I did last time? Let's say I did. Wait, is this what I did last time? No, it's not. Just kidding. I'm subtracting x. I'm sorry. So I'm subtracting x on both sides. So y is equal to 1 minus x. So instead of putting y in my equation, I'm going to put 1 minus x. My bad. So in this equation, 35 times its percent. So 35 times x plus 37 times y. But I'm not going to do y. I'm going to do 1 minus x because that's what y is equal to. 1 minus x. And all that is equal to my average atomic mass, which we said before was 35.4527. Now all I'm going to do now is solve for x. So I'll get 35x plus 37. What's the word that y'all use? Distribute. You're going to distribute these. So 37 minus 37x is equal to 35.4527. I'm going to combine like terms, so I'm going to combine that one and that one. And I'm going to move 37 to this side because they're the same. The way I'm going to move it is I'm going to subtract 37 and bring it over here. So I'm going to subtract 37 on both sides to get rid of the 37 over here. So minus 37 minus 37. So when I combine these two, 35x minus 37x, I'm going to get minus 2x. If I subtract over here, I'll get 1.5473. Oh, negative. Great. Then I can solve for x. Ooh, I'm running out of room. To solve for x, I need to divide by negative 2 to get rid of that negative 2. So divided by negative 2. Classy, right? I know. So x in the end is going to equal, if I divide that number by negative 2, 0.77365. That's what I got in the calculator. Oh, you can't see that. Screw. You can't see that anyways. 0.77365. It is a percent, so let's do 2 decimal places. So when I multiply this by 100 to make it a percent, because remember, to make something a percent, you multiply times 100, x equals 77.37%. Yay. And y is going to equal 100 minus 77.37, 22.63%. And why? Because these two should equal 100, which they do. So great. This one is just like that one. So you can try to figure that one out as practice. I should probably tell you the answer. It's fine. You'll figure it out. Write the chemical configuration for a particle with a charge of -4 and contains 10 electrons and 6 neutrons. So there's a lot of information in this one. If you don't remember what chemical configuration is, that's when we have the symbol, we have the atomic number at the bottom, the mass number on the top, and we're going to put that charge right here. That's the chemical configuration. So first, let's just list everything. My charge right here is -4, so I got that, boom. Electrons, and I have neutrons. So I still need to figure out what the protons are. The protons is going to be what my atomic number is, and I need to figure out what the mass number is. And of course what element it is. So if I have a charge of -4 and I have 10 electrons, am I going to have more more electrons or less electrons? If I have a -4 charge, then I have more electrons because it's negative. Electrons are negative, so I have more electrons. How many more electrons do I have? I have 4 more. So, if I have 10 electrons, then I'm going to have 6 protons then. 6. If I have 6 protons, then I know that my element has to be carbon.
Are you talking to yourself?
No, I'm making a video for the thing.
Oh.
It's for the review. Sorry. Carbon.
Sorry.
Oh, it's fine. Carbon. Atomic number would be 6, because that is the protons. Mass number is protons plus neutrons equals mass number. So if I add those up, I'll get 12. And my charge, it said before, was -4. And there we go. Next one. 82 protons. If I had know this, then I know for sure that it is lead. Pb. It's number 82 on your periodic table. If I have 78 electrons, they don't equal. I have less electrons, so it's going to have a positive charge. How many more protons do I have? I have 4 more protons than electrons, so I'm going to have a positive 4 charge. Next, I need my atomic number. On the periodic table, lead is number 82, or the same as the protons. My mass number, again, protons plus neutrons equals mass number. So, 82 plus 125, 207. Blam. Blam. And the last one. Chemical particle that contains 86 electrons and a +2 charge. So, if I have a +2 charge, then I have more protons or less electrons. Okay? So if I have less electrons by 2, if I have 86 electrons, then I have to have more protons. How many more? 2 more, so I have to have 88 protons. That'll give me a +2 charge. Now that I know that I have 88 protons, if I look on my periodic table, radium, Ra, 88 protons, it is number 88 on the periodic table. It has a +2 charge. I need that mass number though. I don't have neutrons here, so I can't do this. I can't add protons and neutrons. So I'm going to round my mass number. 226 rounded. Oh, well, it's already a whole number, but whatever. 226. And there we go. Yay. Man, this is a long review. Good thing y'all have time. Which alkaline earth metal has the largest atomic radius? Alkaline earth metals are these. This first row. I mean the second row. Column. Dang it. Second column. So alkaline earth metals is this second column. The largest is going to be radium because it has the most energy levels. This has 2, 3, 4, 5, 6, 7 energy levels. So radium has the largest. Which element is a halogen in period 5? Halogens are there. These are the halogens right there. Periods are here. Period 5, halogen, iodide, I. What element has 92 electrons? If this is just an element, then it has the same number of protons, 92 protons. Number 92 on your periodic table is, where are you at? U, or uranium. Name 2 other elements that have similar properties as argon. If they have similar properties, then they are in the same column or group as argon. Argon is here, so you can pick any of these elements, any of those entire group or column. It doesn't matter which ones. You can pick any of the 2. I'll pick neon and krypton. Which transition metals has the which transition metal has the smallest atomic radius? So, the smallest out of all of these. Remember, francium is the largest element. Neon, besides helium and hydrogen, neon is the smallest. So, which one is closest to neon? Zinc. These are the transition metals. Zinc is the closest to neon, so zinc is the smallest. Which element in period 3 makes a charge of -2 in compounds? If it makes a charge of -2, then it has to have 6 valence electrons. If it has 6 valence electrons, then it can get 2 more to get 8 electrons. Remember, everybody wants 8. Or you can just memorize that this entire row always has a -2 charge. Either way, don't matter to me. Period 3 in that row would be sulfur. Okay. Next part. Fluoride ion. Fluoride ion means that it has a charge, so it is F-1. The charge of F would be -1. Number of protons, it is number 9 on the periodic table. If it has a -1 charge, I have more electrons, so I have 10 electrons. Overall charge, -1. It is in an ion because it is negative. Sulfide ion, that'll be S-2. This will have 16, 18, -2 charge, anion. Nitride, it'll have 7, N-3, 10, -3, anion. And magnesium, Mg, will have a +2 charge. It'll have 12, 10, +2, cation, because it is positive. Next part, fill in the table. Pb +2, that has 82 protons. Number 82 on the periodic table. Electrons, +2 charge, +2. If it has a +2 charge, then that tells me I have less electrons. So I have 80. The mass, trigger. If I don't have a mass number, then, and it doesn't give me a mass number, remember you're going to round it on the periodic table. Pb is 207.2, so let's round it to 207. To get mass number, I'm going to subtract mass number minus protons to get the neutrons. So 7 minus 82, 125. Chemical configuration, so it's going to be Pb, says it has a +2 charge. So 82, because that's the atomic number, and the mass, 207. Bromine, 35. Protons, number 35 on the periodic table. I don't see a charge on this, so it is just 35. Number of neutrons. Well, first, mass number is 82, because it says 82 right there. That's the mass number. This is written in hyphen notation. And to get neutrons, remember, mass number minus protons. 82 minus 35, 47. And so the Br, it has a 0 charge, so I'm not going to put a charge. 35, 82. Try to do the other 2 on your own. Cesium ion, there goes that word ion, so I have a charge in this one. Let me write what it is. CS, and if you look on the periodic table, CS is right there in this first column. This has a +1 charge. So +1 charge. So cesium is 55 on the periodic table, number 55, so 55 protons. If it has a +1 charge, I have more protons than electrons, or less electrons, 54. Cesium, the mass, if you round it correctly, will be 133. And 133 minus 55, because that's the protons, and I will have 78. My thing, chemical variation. Got to put that charge there because it has a charge. Whoops. 55 and 133. Shablam. Next problem. Which of the following has a larger atomic radius in each set? So which one is the bigger one? Aluminum or chlorine? Let's go back to our periodic table. This one. Aluminum or chlorine? Like I said, neon is really small. Chlorine is next to it. Aluminum is further. So aluminum has to be bigger. Chlorine is smaller. Chlorine is the... Oh, rats. Just kidding. Aluminum. Aluminum is the larger one. Sorry. Let me just write it down here. Aluminum. Aluminum is the larger one. And if you would like an explanation, it's because they are both in the third period. They are both in the third period, so they both have 3 energy levels. Chlorine, though, has more protons. It has 17 protons. Aluminum only has 13. So like I said, those protons, if you have more protons, the atom is going to pull, the nucleus is going to pull those electrons closer to the middle, so it's going to make it smaller. Whereas aluminum is still on the third period. It still has 3 energy levels, and it doesn't have that many protons, so it's going to be a little bit more spread out. Next, S or SE. Ugh. S or SE. SE has 4 energy levels, so that one is bigger. Na and O. Na is way over here. O is way over here. Na is much larger. Na has more energy levels, and it's further down. Which of the following has the larger ionic radius in each? Okay, so which one is basically larger? +1 or +2? So, like I said before, if it is more positive, I'll write it off to the side. More positive. If it is more positive, then it is smaller. And that makes sense. If it's more positive, then I'm going to have more protons than electrons. And so those protons in the middle are going to pull those electrons closer to the middle. Okay? So this one's more positive, so this one is larger. Out of these two, this one is more positive, this one's more negative, so this one is larger. This one is larger, and oh, let's look at those. SE and P. So, okay, so I need to know how many electrons this is. SE with a -2 charge, that'll put me at 36 electrons. And phosphorus with the -3 charge will give me 18 electrons. So this one would be larger. I'm sorry, I was quick on these because they were the same elements, but if you have different elements and you're comparing them, I have to look at how many electrons they all have. This one has way more, so this one has to be larger. Circle the set of ions that are isoelectronic. So if it's isoelectronic, that means they have the same electrons. So Ba +2, Ba has 56 protons, but with the +2 charge, it's going to have 54, I don't know how to put it. These are all electrons that I'm putting. 54 electrons. Cs with the +1 charge, it has 55 protons, so with the +1 charge, it'll have 54 electrons. Br has 35 protons, so with the -1 charge, it's going to have 36 electrons. Iodide has 53 protons, with a -1 charge, we'll have 54. And Se. Se will have 34. With a -2 charge, you'll have 36 electrons. Next one, sulfur will have 18. Chlorine will have 18. Potassium will have 18. And calcium will have 18. These are all the same number of electrons. So this set, this whole set right here, is isoelectronic. You're going to rank the set that you circled in order from smallest to largest. So let's do small. Oop, don't know how to spell. Small, large. So the smallest one out of all of those. Remember, the more negative, the bigger. The more positive, the smaller. Because if it's positive, I have more protons then. This is the most positive, so Ca plus 2, K plus, Cl minus, S minus 2. Yay. Oh, Lord. Alright, the bell's about to ring. So, for these, on the back, you can come in and I'll have the key for these inside my binder. Oh, also study the mass spec. Wait for it. Alright, there you go. Study the mass spec problems on your in your notes. Make sure that you have, like, when we did you had the percents on the graph and then you have to calculate average atomic mass. Or if you have like particles that come out, then you have to try to add up all the particles, then divide by however many particles you have to get a percent. If you don't know what I'm talking about, look back in your notes for mass spectrometer and try to solve some of those. If you need extra help, you can always come in and I'll help you out. Oh, and good luck.